Ready? I think we decided since we are a full house, we might as well get started, give ourselves a couple extra minutes. So welcome to what I call the story of state. This is a fun talk for me to get going with. My name is Craig Brockschmidt. I'm part of our Windows ecosystem team, and that's the group of people within Microsoft, within the Windows organization that really cultivate the relationships with all the external software vendors, the hardware vendors, a lot of the apps that you see in the Windows Store today are from a lot of our efforts. A lot of the hardware you see out there that was ready on the day we released the system is because we've been working with those people for several years. I've also just finished a book for Microsoft Press, Programming Windows 8 Apps with HTML, CSS, and JavaScript. It's a free ebook. You can go to the Microsoft Press blog and find the download links there. And so I'm thrilled to be talking with you today after having finally finished the book off, having spent most of the year working on it. So when I talk about the story of state, I decided to name this talk with that kind of idea of a story because really looking at the state that an app maintains across its various incarnations is really, in a way, to talk about the soul of an app. Because the state, having a stateful app is what gives you an experience across a lot of different boundaries, that just talking about this or that little piece, just like talking about background tasks, has implications other than state, but there's implications for state. Talking about AppData is very much about state, but there's some other considerations that come in. So really what we're going to be doing in this talk is looking at what we call stateful apps, which Windows Store apps should be stateful, as I will be explaining a little bit more, and looking at it from the perspective of the state itself, from what's really persisting rather than from kind of the app's point of view. So we'll be talking about what the purpose of state is, where it lives, and how it gets modified and what affects it, which goes across a number of different areas. The whole purpose of which is to maintain a consistent user experience between sessions, devices, and process lifecycle events. State is the thing that carries across all of that. So whether your app is being suspended or terminated in and out of memory, whether the user is going between devices, one device to another, whether the system gets restarted or not, state is what keeps a consistent experience across all of those boundaries. So let's talk about what that experience is first, just go over it briefly. Is that what a user sees is that apps really don't start in just some uninitialized state. It's even on first run. So the roaming experience says that if an app, for example, you've been running it on one device, and you did some things, and then you move to another device where the same app isn't installed, and then you go install it from the store and start it up, lo and behold, the state that you roamed from the other device is there already, and the app will come up in a well-initialized state already. Apps also have persistent settings that carry on across sessions, don't need to be re-entered into the app every time. There are things that are user-specific but not device-specific. These are the things that typically roam, as opposed to device-specific settings, like if you've optimized some graphics for the particular display hardware that's in a certain device, that wouldn't roam, but user accounts and other things like that would. The settings charm is something we'll be talking about because this has a lot to do with state. This is where the user goes to manipulate various settings in state that they have control over, that you as an app developer want to provide the capability for the user to do that kind of management. We also need to talk about what's called transient session state, and this has to do with the process lifecycle. That if an app is suspended in the background and the system needs more memory, and so it cleans up some of those suspended apps and terminates them, then you need to have preserved your state so that when the user relaunches the app again, you come right back to where you left off, to preserve the illusion that the app was always running. Because that's part of the user experience, so they don't really are thinking about closing apps and restarting them. They just let them run, and if they get terminated and restarted, we need to work with that as a reality. Something we won't be talking about in this is user data, things like pictures and videos and documents, the things that have an independent lifetime outside of the app itself. That is, if you uninstalled the app, would that data still remain on the system? User data is that classification of state that's not tied to the app. So we won't be talking about that, like pictures and videos and so forth. We want to talk about the things that's really tied to the life of the app itself. So, like I said, state is what carries this experience across all these different boundaries. When an app is running or when it's not running, when it's been suspended, when it's terminated, when sessions start, when sessions end, when you reboot the system, even when you update the app, state can carry across that boundary as well. And that's something we'll be talking about here down at the bottom of what state versioning looks like. because the version of the state that you manage, it can be done independently of the version of the app itself. And the other reason I bring in background tasks as part of this title is that's one of the key things that background tasks can actually accomplish, is the manipulation of state. And as we'll see, there's even a background task that you can use to know when the app has been updated. So if you need to migrate some of the state in the background after an update, there's a way to do that. Let me quickly review the little bit of process lifecycle events. This is a slide more or less from the Build conference last year, so many of you may have seen it already. Just to remind us of that a running app can be in memory. That's when it can basically do everything it wants to. There's suspending events and resuming events where you know that you're going back and forth to the not running stage, or when your code is basically frozen. And just to review, in a suspended state, the app simply doesn't get scheduled for CPU time. Everything's still in memory, everything's still instantiated, so you don't have to do anything really special to handle resuming. But you're just kind of knowing that you're not getting to run code at that time, with the exception of some background tasks. So that's why I have that coloring in green, and so you can see app code that's in a background task can run while the rest of the app is suspended. And of course, again, if there's low memory resources, the app can be terminated, and that's the case in which we want to be able to rehydrate its session state later on. So just to show a little bit about what we mean by stateful apps, let me switch over to my machine here, go to my start screen, and just run an app like OneNote that if, here's my demos for tomorrow. There's my demos for today. There's some of my other notes. As you can see, that app came up exactly where I left off. In fact, this is the screen I was going to be showing when it came up, but I did some other editing before this session, and I had rebooted my machine, and lo and behold, the app comes up exactly where I had left it, even if it wasn't exactly where I intended. To put it in a little more, to show a little bit more about the coding thing, I want to run this little app that I have. It's called Here I Am. This is the way my son used to announce himself when he was about 3 years old. He'd poke his head around the corner and say, "Here I am." So this is my version of Hello World that I develop in my book. I start from where you can take a picture on the left. Here's oh, there we go. Okay, boom, here I am. And it's supposed to get geolocation, but apparently the IP address that I'm talking to is down in California. So let's fix that. Let me actually go up here and repin. Got to get all the way up here into Washington. Let's zoom in. Oops. Okay, where's Redmond? Where are we? I'm getting there. We are all the way up around here. There we go. My mouse wheel is too fast. Where are we? Woodinville, Redmond. Where are we, Redmond? Down here. There we go. I'm going to find building 33. There we are. And we are just about exactly in there. I think that's close enough to where this room is. So here I am. So this is the state that I've put the app into. Now, if I just left this app is written to be stateful, so it's going to remember everything about what picture I am, where my current geolocation is. And if I as a user closed this app and restarted it kind of back to its default state, I wouldn't see this. But in Visual Studio, if you go to simulate a case where you're going to be terminated because of a low memory condition, use this little command here called suspend and shut down. And what that will do is we'll simulate exactly the case where you ran out of memory in Windows and terminated the app. So we won't see it in the stack anywhere at that point. Now let me re-enable my breakpoint so we can see what happens when we relaunch. So when we restart, we come into the app's activate event. I'm showing this in JavaScript because that's what I wrote this particular app in. And in the activated event, you'll see that the args detail has this flag called previous execution state. And if that happens to have been terminated, this is the signal that says, hey, we dumped you out of memory. Preserve the illusion that the user never actually shut the app down. And so you'll see what I do here is I set this flag init from state. That will take me into what's called my page control on this function here. And basically what I go through doing is reloading the image file that I had last used. I also reload. It's done more automatically for us in this WinJS session state object. But basically, when I run that app and go through that code, you'll see that we are exactly back to where we left off, which is very cool. I didn't get that geolocation from California and so forth. But this is the kind of experience that we're trying to reserve across sessions for the user and across any kind of lifetime event that may be going on. So let me give you this as the big picture that really is the important one to grasp. So across the top, I have a number of different kind of the way an app is running or not running, and some other events like restarting the system, which is definitely a shutdown, and other devices, meaning the roaming experience. What I really want to show here is the different the different kinds of places that you store app data or app state in one way or the other, and how they stretch across these particular boundaries. So anything you manipulate in memory, shown in green here, is preserved across running and suspended states of the app. No problem. Then there is a section of your hard drive called the local and temp app data areas, modified by Windows Runtime APIs and other APIs built on them, such as various database options we have and other HTML5 things like app cache and local storage. All of that goes into these particular folders or settings containers, as we will see, and because it's written persistently on the drive, that will persist across lifetime events of the app as well as lifetime events of the system. So oftentimes you'll see this is even probably going to be persistent across even updating the system from, say, Windows 8 to whatever future version comes along. It's just stuff on the hard drive, belongs to the app. It will be there the next time the app runs. Roaming app data, which goes through the same APIs as local and temporary, works the same way, and you can use it just as you can local, but that also roams across devices if, in fact, the user has allowed it. There's a setting in PC setting where the user can turn on and off whether app state gets roamed. So they do have control over that. Ultimately, there's nothing an app can do about it. Your job is to write whatever is appropriate to roam to other devices in that section of your app data and let the rest of it take care of itself. And then there are two other areas that are kind of a bit less known, things that we really haven't popularized very well that you may not have even heard of, but are in the WinRT APIs and are actually incredibly important for dealing with state. The first one is called the access cache. Now, if you've worked with Windows 8 apps for a little bit already, you'll know that there are only certain areas of the file system that you have programmatic access to by default, like your app data folders. And if you declare certain capabilities in your manifest, like pictures library, videos libraries, and so forth, you can have programmatic access there as well. But anywhere else, the only way you get programmatic access is by going through the file picker. That will give you back a folder or file object that the user has basically consented to say, yep, I pointed the app to it, so yes, you can talk to // whatever random folder you want to. Now, what we would normally do in ages past with that kind of a situation, when we wanted to preserve like the last location a user was doing something in, we would save the path name, right? That doesn't work in this situation. If you save the path name and come back later and just try to open that folder or file again with the path name, and it's not in a place where you have inherent programmatic access, you will get an access denied exception, unless you store it in this object, the access cache here. You basically take the folder or file object, you park it in this access cache, you get back a token, and then when you restart, you get that token again, and you ask the access cache to give you back the file or folder. That's how you preserve programmatic access to file and folders across these boundaries. It's a very important API to know about, and we'll be looking at that a little more in a bit. And then the final one down here is this thing we call it the credential locker. The API says password vault, but we had a little trademark issue around that. So in the documentation, we call it the credential locker. This is where you store anything that you want to have secured and encrypted. Now, you can do encryption and stuff on your own and just store things in local app data. That's okay, but if you store it in the password vault, you don't have to worry about that kind of security concerns. And especially with things like credentials, that's also synced for you automatically. So there is another setting in PC settings where a user can say, sync my passwords. And if they do that, this is what data actually gets synced. So if you have a user log into your app on one device, you've saved the credentials in the credential locker, they go to another device, That data is roamed across with everything else. They start the app, and lo and behold, your code finds those credentials and provides a seamless logon experience without ever having to ask again on that device. Wonderful experience, but this is the API that makes it work. Okay. Let's look at some of the code, starting with what we call settings. Now, in the local and roaming areas of your app data are these things called settings containers. The settings container is basically an object that manages key value pairs. And so through this windows.storage.applicationdata.current.local settings, you got to love some of these names. Some of them get really, really long. When you get that particular thing, that's a settings container. It has a property called values. That value is a map that basically lets you say, here's a name and here's a value. As I say, here's a property called message, or a setting called message. I'm going to give it the value hello world. That's all you have to do to store them, and it gets written to disk. You can, instead of using local settings here, you can also say roaming settings, and it works the same way. You can also then create a hierarchy of settings containers within this. So the local settings container itself has a method on it called create container. That gives you another container with whatever name you give it, and it also has a values property map that you can then save and retrieve values from. So that's for a lot of little key value pair settings that you want. You also get the ability to do files, just whatever random file format you'd like, which works for temporary, local, and roaming. And the difference between local, as you see, I'm using roaming folder here on that first line. There's also temporary folder and local folder. Temporary folder is one that you would use for temporary state, and it's subject to the disk cleanup tool. So if the user runs that tool and says clear out app stuff, that will get deleted automatically for you. So that's the distinction between local and temporary. But otherwise, all three of the folders work the same. You get a storage folder object in which you can create files of whatever format, whatever size you want, and write text to it, and then anytime later, go ahead and open that file and read it. Now, you notice here that in this last line, I just am opening a file with a file name. Because it's in my app data, I have inherent programmatic access to that. And yes, you can save file paths and relative path names and whatnot to that area and reopen them that way. That's no problem. The access cache is needed for everything else. Okay. There's also something called a composite setting, which is to say if you have a group of settings, going back to the settings containers and not the files, if you have a group of settings that you want to always be managed as an atomic unit so that they either all get written or they don't get written at all. And this is very important for roaming, where you want to make sure that a certain packet of data always gets roamed together or not at all. That's what a composite is for. Composite basically just gives you, what looks like another property map that you can store whatever values in. One thing is very interesting, a little feature that we added somewhere earlier this year, we didn't have it in the first developer preview last year, is that if you create a setting, not a container, a single setting with the name high priority, so it can be a composite, so you can put a bunch of stuff in it, and it's under 8K in size, and you put that in your roaming settings, then we will try to roam that within a minute, as opposed to the normal 15 to 30 minute interval that's normally applied to roaming. So if you have, like you're playing a video and you pause it, you want to take that position of playback, roam it over to another device very quickly, this is your friend. If you have game state, you want to roam over to another device quickly, this is your friend. So it's a very nice little feature to have in there, and I want to make sure you were aware of that. The other little thing that comes up with state is this little event called data changed, which comes out of, again, Windows Storage Application Data. This tells you in your app that something in your app data has been modified from outside of maybe your awareness. So if data has been roamed from another device onto the one that you're running, and so Windows has written something into your app data folders, in this case specifically your roaming folder or your roaming settings, you will get this event. And you can say, oh, there's some data here. I want to reload that. I want to refresh my state, do whatever conflict resolution I need to do. Because, by the way, with roaming data, we made the decision to say, we're just going to do last writer wins with whatever's in the cloud. So if you got 2 apps running at the same time, whoever writes last wins as far as the cloud storage is concerned. Went through all kinds of iterations to try to figure out a better way of doing this, and we said, no, let's just keep it simple. So this is where you would do the conflict resolution here if you needed to handle something like that. But in any case, it makes a really nice place. You can also, elsewhere in your code, signal this event to yourself if you want to. So if you've written some data down and you have all your handling here for different kinds of app state you might be managing, you can signal that data changed event to yourself, and boom, you're right here in this handler. So something to make sure you're aware of as well. Okay. So this is what the access cache looks like. Pretty simple API. Windows.storage.access cache is your namespace. And by the way, the code here looks pretty much the same in C++. It looks pretty much the same in JavaScript, with the exception of having this really nice await keyword in C#. JavaScript's a little messier. But it all pretty much flows the same. I use C# in this talk because it's the most concise. So anyway, with the access cache, I'm showing here using the folder picker to get a storage folder object. And then I'm saving that in this thing called the future access list. That's what Windows gives me this object to say, here's where you store things that you want programmatic access to in the future. And I just use add or replace with some name I make up for a token. And then later on, I can use that same token through the future access list get folder async method and get that storage folder back. So this would be code I would do on startup rather than somewhere else in my app. And in fact, let me switch over back to this app again. And you'll see that here, let me find the, here in this particular function of that Here My M app, when I'm updating the image, you'll see that I come through here, I show it in the image element, and then I get the access cache and basically store it. And I'd use either the add or replace, depending if I already have one stored. And then during startup, you may have noticed this code earlier. On startup, when I want to rehydrate my state, I check to see if I have a file token. If I do, I use the access list to get that file back, and then I can basically go through the same process again to show it in the image element. So very simple to use, but very powerful and effective, and avoids all those nice access denied exceptions that we don't want. Okay. Credential locker I mentioned before. Again, this is where you want to store anything you want to store securely. Now, you don't need to just use it for passwords. You can use it for access tokens that you get from some other authentication process. Anything else you want to store securely, you can throw it in the credential locker. No problem. And again, on trusted PCs, these things are roamed automatically for the user. The other thing I want to make you aware of in this context is there's also a dialog box built into the system called the credential picker. How many have known about this already? Yeah, see, there's like 3 people in the room that have actually heard about this. You don't need to build login stuff for yourself. If you've started building login screens, there is a credential picker API that gives you domain logins, gives you smart card logins, as you can see here, gives you all the control over what captions and messages and options that show up in that particular UI. And on domain machines, we'll even store the credentials, domain credentials, into the Active Directory service as well. So very, very rich. There's a sample on it. I have a URI here you can go to, or just search for the credential picker sample that's in the SDK. Using these things, again, like you find in WinRT, there's just a few lines of code that you need to do. In Windows Security Credentials, you will find these. To invoke the credential picker, you create some options where you set things like captions and messages and what security protocols you want and whether the save password checkbox should appear and all that. The other really neat thing it does, by the way, is if you use the credential picker once and you get back some error message or some error code from it, and if you look in the Win32 error codes, there's like 15,000 different options there. You can take that error code, stuff it back in the credential picker options, and then give it a flag that says show error message, and it will go out and find the right localized error message to pop up in that dialog. Very, very handy. So if you've generated, you got the credentials back, you tried to validate it, you had the wrong password, or a password's expired, or the domain user's not found, all of that kind of thing, you pick the error message and stuff it in this option, send it back to the credential picker, and it will show an appropriate message for that. So you do credential picker, pick async, gives you back a result. And you can see here that to use the credential locker, you just create this thing called a password credential, stuff in the username, password, whatever you want to do, and park it in that locker. And then later on, you can retrieve it with the same little token here, mycreds. Basically gives you the way to get back at that. Okay, so we've kind of burned through a number of the kind of built-in WinRT APIs for managing state. We've seen the AppData, roaming, high priority roaming, settings, composite settings, settings containers, and then the access cache and the credential locker. There are a few other things that are built on this that you should know about. People always ask, where is the database option for doing AppData? And the best thing there we have right now is SQLite. You can go to Tim Hewer's blog here to get the information on that. It is simply an API that uses local AppData to manage its state on your behalf and give you a relational database. If you want a database kind of thing and don't need the relational side of things, you can use the ESE/JET APIs in Win32. Those are available. And if you're in JavaScript, you got, again, IndexedDB, local storage, and app cache, which all work for apps written in JavaScript. All right, versioning. So when you create stuff within your AppData, so anything you write in your temporary folder, your local folder, your roaming folder, your roaming settings container, your local settings container, all of that together has a version. It has some structure that you've decided is probably, when you start, your version 1 of your state. There is an API called setVersionAsync that's on Windows.Storage.Application data, and that basically sets the version number on it. Now, if you were only ever doing stuff locally, this would be just what you would see if you got an upgraded app, and it's installed and you run again, you check this version number and you see whether some of that state needs to be migrated to a new version, and then you would call setVersionAsync again. Where this becomes really important is with roaming. If you have so imagine you have a user with 5 different devices that all have, version 1 through 6.8 of your app, and all of those versions of your app use version 1 of your AppData, okay? And then you issue version 7 of your app and you upgrade your app state to version 2. And then the user installs that new version, your version 7 app, AppData version 2, on a new machine, on one of those devices. And you start doing roaming, what happens? Well, what happens is that Windows will see, oh, I have a version 1 app state and a version 2 app state, and I actually keep those two separate. So at that point, we're not doing anything complicated there. You basically now have a version 2 of your app state that's going to roam independently of the version 1. So the 4 devices that still have version 1 of the app state will continue to talk to each other, but they will not interact with the version 2 of the app state on the 5th device. Now, those 2 versions of the app state will be maintained in the cloud until all those different clients have been updated. So when they all hit version 7 of the app and they've all migrated and called setVersionAsync to version 2 of the AppData, then the cloud will say, I don't have any apps using this anymore for this user, and I can finally clean it all up. So it's very much something to be aware of how this versioning will affect that roaming experience. The key thing is that you will probably very seldom update your state version. Like I said, you can have many versions of your app that use the same version of the state. This is why I'm telling the story of state, because it persists and has a much longer lifetime than the versions of the apps themselves. When I used to work in the SQL Server organization and we were talking about data access technologies like Entity Framework and ADO.NET and those kinds of things, we would joke that data is the thing that's really permanent. And apps are just like ephemeral. They just kind of come and go and disappear and go in and out of memory, and they get versioned all the time. And, the IT department retires one set and invents a completely new set, but you know what? The stuff in that database keeps on living. And really, if you think about it, it's because, stuff in a database especially, it's the facts of our existence, right? It's when I was born, when I got my social security number, things that actually never change for eternity, because me is this person with this identification, and these kinds of qualities, they just don't change. So that data lives on and on and on. So your app state's kind of in that same sort of boat. So your apps may change a lot, but your state may be very, very persistent. So even if you're doing things like if you're using a SQLite database, you may do another versioning scheme inside the database that doesn't need the app state version that Windows is managing to even change, because you're managing that on another level. So again, you don't need to change the version of your app state very often, but if you do, you need to set the version. And there is this thing called the servicing complete background task trigger that you can use. This gets fired whenever your app gets updated from the Windows Store, and you can attach a piece of code to this trigger that will go out and run when that happens. So before the app actually gets launched again, you can have your background task run and do that state migration automatically. So you don't actually have to build that logic into your app itself. A very convenient thing to have around. Okay, now let's talk settings. It's fun when I put together a talk like this. If you just want to talk about AppData, there's so many APIs in there. But then, well, settings is intimately related with that because this is where you put the UI of your app that will typically manipulate app state and typically write things to the AppData and write things to the settings. So as you've seen plenty of times, if I go over to this machine and I do Windows key I get the settings panel. And it's not showing on here; it's showing on this one. Let me do it on this machine here. Let me go back to my app here. Actually, let me run something different like OneNote and do Windows key I, and you'll see a settings panel fly out. We did the settings on the charm because if you think about it, search is ubiquitous for almost every app now. Share is almost ubiquitous. Device is a ubiquitous experience. And just about every app has settings. But if you go back historically, you find that apps kind of park these wherever they feel to. They may be on the Edit Preferences menu or Tools Options or in the File menu, something else. So finding this stuff has always been tricky. And then when you do it, you have to kind of integrate it into the app's navigation hierarchy or some of its other structures. And for Windows 8, said we can simplify this by making a universal place where users always go for settings. They swipe in from the edge, hit the settings charm, and they get some kind of panel here with commands listed on it. And we can guarantee that you always have something here because apps from the store will always have a rate and review. That's guaranteed. And typically apps will also have a permissions command on there that lets you manipulate things like whether you allow it to use the webcam or not, whether you allow it to use the microphone, geolocation, and so forth. So that's what we have for that. And let me go back to here. So settings, I think it's a really nice design because I don't like building this kind of stuff into my page navigation hierarchy of an app. It's nice that all this is just separated out into its own little UI areas. I can write these as little mini settings apps and put whatever UI I want. And typically what happens is when you manipulate the controls in that particular settings flyout, you'll modify AppData. And then you can use remember that signal data changed method that I mentioned that will trigger the data changed event. Well, you can just change everything, fire that off, and have all your handling code in one place within your data changed event. It can be very, very handy that way. This is also where you want to put, there are some UX guidelines on putting things like account management in here. So if you manage with logins and terms of services and all that kinds of stuff, you put it into the settings charm. And does that, there we go. The way it works, it's again just a little bit of code that you're writing. You respond to this commands requested event. That's what gets fired to your app. If you're listening on this object, you get this event raised whenever the user invokes the settings panel. And then you do what's called populating the commands. So those commands that you saw listed, some of them come from Windows, but the rest of them come from the app itself. And what you can basically do in here is either provide commands that will invoke another piece of UI, or you can just put links in there. So it's perfectly fine to put hyperlinks in there that just go to the browser. You can also build a panel that has a web view or an iframe in it that just shows remote content from a web page. Nice, easy way to implement localized privacy statements in terms of service and that without having to build it all into the app itself. These are the controls down here you'll find for doing this in both XAML and WinJS. Pretty simple to use there. So let me switch over to this box again and just show that quickly. Where is it here? App settings. We'll use a C# sample here. This is one of the SDK samples, and Just as a general note, by the way, if you haven't spent time looking at all the SDK samples, there's hundreds of them out there. They cover like 98% of the APIs. And like you can find just about anything you need to do in an app in one of the samples. So a sample like this shows all these nice little scenarios. You got the reference code you need to do it. So without any kind of, in this app it's showing without doing anything with the commands requested event, you'll see that it has a permissions setting command automatically given from Windows. Here's a piece of code that gets executed, adds a few more commands, and in this case it just reports back to the app that it was selected. But this one also then shows a UI panel that's very rich that shows it has a bunch of controls in it. And basically you can make controls, you can make it scroll. You don't want to make it pan right to left, but you can scroll vertically definitely. The other piece of design you want to consider within the settings panel is that whenever you change a setting, it's applied automatically. We don't have OK buttons or apply buttons in these panels at all. So they should always be reversible and always applied immediately. That's the UX guidance that we have there. So just to show the code for this quickly, it's not terribly complicated. Here's a typical commands requested event or event handler. You can see it's creating an object called a settings command. I believe this comes out of, I forget which namespace it is, but it's up in the code. Basically says, here's my identifier, here's the name that should show up on the panel. This is a piece of text you should localize if you're going to international markets. Here's my handler here. That handler you can see goes to onSettings command. Let me go to that. OnSettings command basically creates some UI, and here's your settings flyout, and creates it and shows it. And then it's a piece of UI. You have a piece of code for that. You get all the events for all the controls, and you do whatever you need to do with AppData. So it's not particularly complicated, and is exactly what you need to do the settings. Okay. All right, so now let's cover the little detail about background tasks. Background tasks are, if you're in the .NET world, you know about the task object. That's how they run. We'll see an example of that in a minute. If you worked in JavaScript, background tasks run as a web worker. So they're off the UI thread, they run, and they can basically do just a couple of things. Number one, they can't do UI. You can't do UI from a background task. That will throw exceptions all over the place. But you can manipulate app state. That's one of the biggest things that background tasks are made to do, is change app state. The other thing they can do is issue tiles and notifications, things like toasts and tile updates and so forth. Want to know about that? I'm going to be talking about that tomorrow morning at 8:30 in that context. But so let's look at the background task from the perspective of state and the kinds of things you would use for that. As we'll see in just a minute with the code, you build a background task. There's this little object called the background task builder. You tell it what trigger you want, some of the conditions that you want to apply to it, like whether or not internet is available. Then you register the background task, and then whether or not your app is running, it knows where to find, Windows knows where to find the piece of code that it needs to execute when the trigger occurs. So there's one class of triggers called maintenance triggers. These just run periodically. You can specify the period that's at least 15 minutes, so no shorter than that. So sometimes you're going to be doing things like maybe every 10 days or every 30 days or every hour or whatever you need to do. As long as the system's on battery power, these will run, and these are great times to do things like just chew on your app state. If you got temporary files, it's a great time to clean it up. So it can simplify your app logic to say, well, instead of trying to clean up all my temp files in the code that I'm using them, I'm not really sure when I'm done with them and whatnot, you can just build that logic into a background task and have it run every 5 days or something to that effect, and then it can just go out and clean out anything you know is too old. So it can, again, just very much simplify your logic there. There's a set of system triggers for things like the internet becoming available or other network state changes. Great way to handle app state related to connectivity. And this one called Service Incomplete that I mentioned before, that is what tells you your app has been updated from the Windows Store and is a great time to manage any state transitions. These also only run on AC power, and if the user has the system locked, they don't run at that time either. There are a few background tasks that are lock screen only, that if the app has been added to the user's lock screen, it's again something I'll be showing tomorrow morning in my session called Live with Activity. then you can basically have a few more options there about when sessions get started, when the user logs in, logs out, when they're away or present at the computer. You can also add things like time triggers, so if you want to do an alarms app or something like that, that's the category of triggers you have there. But generally speaking, there's a lot of different options for background tasks, and again, managing state is one of the key things that background tasks can accomplish, and one of the key things that they are actually allowed to do that if you go back to that previous diagram, you'll see that there's only so much a running app can do when it's running, and when it's not running, how do you get stuff done? You use a background task. One of the notes I'll make about this you should be aware of is that background tasks do have quotas on how much CPU time they can consume and how much network activity they have. All of that is to help preserve battery power. So if you're, and that's specifically for the lock screen triggers, but it's also to make sure that we don't have a bunch of background services running that just make the system crawl. I mean, okay, admit it. Every one of you has probably gone to Task Manager at some point, found what the hell is chewing on my CPU, and kill the damn thing, right? Because there's something running on my machine. My hard drive light's on, and I'm not doing anything. Like, I just rebooted the system. What's going on? So we want to prevent that kind of activity from going on with these background tasks for Windows Store apps. And that's why we have these kinds of quotas in here. Something that I will mention that I discovered in the process of writing my book, and you'll see in some of the samples, is that if you're writing an app in JavaScript, you can write a background task in C#, C++, or Visual Basic. If you're writing an app in C++, you can write a web worker in JavaScript and have it run as a background task. Very cool. You can actually use whatever language is most appropriate for your background task that's independent of the main app, because it doesn't run in the same context. It runs, like I said, either as a .NET task or as a web worker independently. And so knowing that there's a CPU limit, you can say, oh, I don't want to write this chew on my hard drive code in JavaScript. Maybe it'll be more efficient if I write it in C++. You can make that choice independently of your main app. So let me show just the structure of one of these. It's not really something that's too easy to demonstrate, but I want to show how a background task is built and registered and its own structure. So this comes out of the raw notifications sample, something else I'll be talking about tomorrow morning, where there's one of the triggers that you can have on the lock screen is a background task that will respond to the arrival of a push notification. So that's the thing here, push notification trigger. You're seeing that I create a instance of background task builder. I create a trigger. I can set other conditions on it if I want. So I can say, only fire this if a push notification arrives, and I do have internet connectivity, which is typically the case for a push notification. But you can condition it that way to make sure you only run when you have to. You set the task entry point, which in this case is basically a pointer into this piece of code here. And the name of it, which is just an identifier, you call the task builder register, and that will set it up to run when it needs to. You can also, as you see here, register for a completed event, so that if the app is run, it registers a background task, it gets suspended in the background, that task runs in the meantime, and then you get resumed, that completed event will fire, and you will know that that background task ran, so let me go check to see what app state it might have modified. The structure of a background task, you can see over here in Solution Explorer that this is actually contained in a separate module from the main app, which is again why you can have these written in different languages. And basically a background task in C# at least is a class derives from iBackgroundTask that has one method called run, and whatever code you stick inside the run method is what runs as a background task. Very simple, straightforward to do. And you can see here a great example of we're getting the AppData local settings and stuffing into that right here the content of the push notification. So there we have it, being able to save our app data when we get a background task. Okay, so let me just wrap up now with a couple slides of kind of some of the best practices we've found and some of the other hints that you'll need for dealing with state. So you'll need to think about the logic of your app's launch paths and your activation code. Checking that terminated previous execution state flag to see whether you were terminated, making sure you're launching with intelligent defaults if it's not that way, or rehydrating your app state as appropriate. There are some helpers for this. If you look in Win.js, you'll see there's this object called the application session state. This is just an empty JavaScript object that you can park whatever variables in it you want. And whenever the app is suspended, that gets serialized to disk. And if you get restarted again, from the terminated state, Win.js will automatically reload that particular session state object. And you will have all your variables right there. I use that in that Here I Am app. And it's just a place I can park variables. And I use the variables in session state all over the code. And I just never have to think about specifically saving those pieces of state separately. It's just done for me automatically. There's another little piece of code that you'll find in a lot of the C#, Visual Basic, and C++ samples called the suspension manager. Basically serializes a similar session state object into an XML file in your local AppData. You do need to do a little more wiring to handle the suspended event within the app, but you'll see this used in the samples a lot and just gives you a nice little piece of wrapper code for that. We do highly recommend that when app state changes in your app, you go ahead and save it incrementally. Which means, you're typing along, there's an idle moment there, you save that paragraph. You tab through a form and you're filling stuff out. Go ahead and save those little pieces of state as they change. Now, normally you might think that, oh, well, why would I do that? Why not wait till file save commands and things like we've known for many, many years? Well, if you think about the way Windows Store apps run, they're running in the foreground and just about everything else is suspended in the background, with the exception of the desktop. But say you're on your new Surfaces you have, where you don't have much of a desktop, then the app that's in the foreground basically can run the table on disk activity and it's not going to be a problem. So writing small pieces of state, writing to the local settings containers or the roaming settings containers, it's just not a problem. And this means that you really, by the time you get a suspending event, you probably don't have to care anymore. Everything's saved. And then if you restart, it's just there to be reread. And like I said, we've said save all file references. Other things, if you don't have inherent programmatic access to a file or folder, save that in the access cache rather than saving a path to avoid your access denied exceptions. Save your passwords in the credential locker, and be aware that there are also in the Windows.storage namespace and Windows.security namespace, there are some compression and encryption APIs built into WinRT. So if you need to encrypt something on your hard drive or in your settings and in your state, there's an API for that. If you want to compress, say, minimize the size of your roaming settings, which I didn't mention before, but there's a quota there. It's about 100K right now. That if you exceed that quota, we will not roam the data to keep the roaming under control. So if you think you got a bunch of data that can be compressed that's going to take up 50K and you can get it down to 3K with compression, there's some APIs you can use for that. We talked about restoring your transient session state, whatever you need to after being terminated. Typically, this is pretty small, not too much to care about, but makes a big difference in the user experience. You do want to be aware that there are some cases where if you're launched through protocol activation, if you are launched to service something like the share contract, but not the search contract, because that's kind of more of an app launch. These are some cases where you actually don't rehydrate the app from a previously terminated state. There's some guidance on the Windows Developer Center that goes through these different cases. And the last thing I'll mention is with the resuming event, going back to that lifetime diagram we had before, an app can get suspended anytime it's in the background, and when it gets resumed, it just gets CPU time again. Well, you as an app writer have no idea how much time has elapsed. It could be a second since you've been suspended. It could be a day. It could be a week. It could be a month. It could, who knows? It could be 6 months if the user never reboots the machine. So if you have any time-sensitive data, such as stuff that you've cached from an online service, or like if you're a news reader and you want current headlines, one piece of your app state to save when you get suspended is just a timestamp. And then when you get resumed, you get another timestamp, check the elapsed time, and then make a decision on whether or not you need to refresh some of that data, because a lot may have changed. Or like with the Here I Am app, I will refresh the geolocation if I was tracking geolocation automatically, which I'm not. But if I was, I could resume. When I resumed, I'd check to see, oh, has it been more than like a minute? And if so, maybe I want to refresh the geolocation, because the user has probably moved in that amount of time. So with that, the idea I'm doing this talk tomorrow morning, it goes a little bit more into some of the background tasks and other things with tiles and notifications. The other 2 talks I have listed on here, yes, I know have passed, but they are kind of your basic introduction to writing apps in different kinds of languages, which give you the framework for where app state would actually fit in. More importantly, though, are these different samples. You can search for these on the Dev Center by name, and then my book as well. I got a whole chapter on this particular subject and a lot of others. And then the obligatory slide they added to all of ours. Please fill out these session reviews and evaluations. And with that, I'm happy to take any questions. Yes?
What happens to like pending waits on like saving settings and stuff like that while your app is getting suspended?
So the question is, what happens to pending operations, basically, especially if you got asynchronous ones?
Yeah.
So there is a mechanism in the suspending event where you ask for a thing called a deferral. And you ask for the deferral, and then once you do that, Windows will not suspend the app as long as you're still within the 5-second time frame until you call the deferrals complete method. So what you would do if you had an async operation is you would get the deferral, launch the async operation, and once it's complete, you call the completed method of the deferral. So in C# it's easy because you just throw the await keyword on there and it looks synchronous. In JavaScript, you put that deferral completed call inside the promises completed handler. And then you get, yeah.
How's version information handled on PowerPet? So let's say you're serializing version 4, PowerPet happens, and now you come back and what happens?
So that's a really good question. What happens if I'm basically writing my app data, the power goes out, the machine dies, what happens to it?
What version comes back up?
Yeah, to be honest, I don't know. If you can track John Sheehan down, he's given one of the talks here. He's worked on that stuff very directly, so I would try to track him down, see if he knows. Another one? Yes, here.
Is it possible to share session states between two different apps?
Is it possible to share session state between 2 different apps? No. Session state is managed on a per app basis in the folders that are down beneath its kind of package areas in your local app data. We at one point were considering having packages that could contain multiple apps and then would share that. We cut that for Windows 8, but we're considering it for future versions. So right now, no. But you can roam that up to your own web service if you want to. So that's the mechanism would be to use a web service if you want that kind of app-to-app communication. That's always working. Of course, depends on internet connectivity, but that's the way it works today. Yeah, yeah, in the back?
When using access cache to preserve the file selection, is it safe to assume that something like a SkyDrive file will be synchronized? Or is it better to have the user pre-select it to ensure that it's synchronized?
Yeah, that's a really good question. I didn't go into those details, but let me offer that now. So one of the reasons why the access cache is important, and did I repeat the question? Okay, well, the question was if I'm using, get us like a storage file or folder from SkyDrive, is it better to just have the user repick that because of synchronization issues and so forth? Okay, so the first part of the answer to that is, if you've looked at the file picker, you'll see that you can not only pick things from the local file system and from cloud services, but you can also pick stuff that other apps are providing. And what you get back is a path name in the storage folder or storage file objects. Who knows what it is? It could have any kind of structure, and that's why just saving a path name and trying to use it later also wouldn't work very consistently. So that's why also we have the access caches to handle those kind of strange file locations that are being served up by other provider apps. Now, there's this other thing within the Windows.Storage API called the cached file updater. When you deal with files and folders, and I didn't show much of that, about opening the files, and then there's kind of a protocol that you use to say, if I think this file has come from some remote source, and I'm saving to it, I can basically tell Windows that I'm doing that kind of an operation. And then the provider that's on the system, like the SkyDrive app, will have this cached file updater interface that it's working through, that it will handle a lot of the synchronization. So what will happen is You have opened the file. It's done a synchronization from the cloud to your local file system for its copy. You've saved that storage file in the access cache. Everything's shut down. You restart. The file's changed in the cloud in the meantime and hasn't been resynchronized. Your app runs. You load that storage file from the access cache and you say open. That open will trigger a synchronization automatically through the cache file updater interface. So there is a mechanism for that to go through.
But that doesn't have to, we wouldn't have to put that in our code from the access cache.
Yeah, that's right. You don't have to write anything in your code. You just basically, the access cache will take care of triggering that synchronization automatically. It's only when you're writing to a file that you have a couple of extra calls that you want to make to say that there should be a synchronization there. But it's really boilerplate code. Yeah. Any other questions? Yes.
The credential picker, does that include support for logging in via Twitter and Facebook and those?
Yeah, good question. Does the credential picker deal with basically web authorization? So the answer for the credential picker is no, but there is another API called the Web Authentication Broker that you use to authenticate the app through Facebook, through Twitter, through basically any OAuth provider. So through Microsoft Connect accounts, and it works with OAuth 1 and 2 both. And there's a great sample on that shows you how to do Facebook, how to do Twitter, which is an OAuth 1. Facebook's an OAuth 2. Microsoft Connect, which is OAuth 2. And I think there's one other in there. They do another OAuth 1 example. OAuth 1 is really messy. OAuth 2 is much cleaner. But you want to see the Web Authentication Broker as the piece used for that. And that basically gives a system UI that pulls up the web page, whatever you point to do the authentication through the website. And then you tell it what page it's going to go to when it's done, and then it will come back to your app. So that's built in. Yeah. Was there another question over here? Yeah.
On background tasks, I know there's every 15 minutes you get like 2 seconds of CPU time. Is that across all background tasks or just the timer task for a lock screen?
So the question is the 2-second CPU time per 15-minute limit. Is that across all or across one? I don't quite know. I don't quite remember from when I read through all that. I think it's across all of them, but I could be wrong.
Maintenance triggers and total timer triggers and for all those things?
Yeah, I think the lock screen ones have another. They're separated, so the time trigger would be separated from the maintenance task. But I'm not totally sure on that right now. But yeah, good question. I don't have the answer. Okay, one more. Yeah. Okay.
So I had 2 questions. First off, are any capabilities needed to access the credentials locker? Like, do you need enterprise authentication in order to do that?
Yeah. So the question is, do you need any certain capabilities for the credential picker itself, the credential or the credential locker?
Yeah.
So the credential locker actually works outside of. It's separate from enterprise authentication. So if you're using the credential picker and you have the enterprise authentication capability is more about whether you're automatically communicating credentials to services like SharePoint and so forth. And that does require enterprise authentication, shared user certificates, and whatever there's three capabilities that all go together. That will affect the activity of the credential picker API and how it deals with domain names. And when you say save the password automatically, there's a flag for that. If you don't have those capabilities, I don't think it will save it into Active Directory. So there's kind of a table. I have it in my book, and I think it's in the networking chapter. And the book is free, by the way, so there's no excuse to not download it, even if you're... And basically, a good half of it has nothing really to do with JavaScript. It's basically WinRT. So in the networking chapter of that, I do have that table or describe kind of where that particular condition ends up. That I got from the networking team, kind of went through all the different variations with me. So, yeah. And your second question?
My other question was, so control channel trigger is not available on JavaScript apps. Can they be used from C++ modules inside of JavaScript apps?
Yeah, so the question, he's referring to control channel trigger background task, the trigger there, which doesn't have a good way to handle it in JavaScript. But yes, you can have a C++ component that handles that as a background task and then communicate through app state to a JavaScript app.
Is that only if the C++ component is the one creating the socket, like in the JavaScript component, if the JavaScript app creates the socket and then hands off?
Yeah, if the JavaScript app creates a socket, I don't think you can share. You can't really share variables across that boundary. So it would you can share it through app state, through the AppData stuff persistent. But you're not going to share a socket connection. You can share the the URIs and stuff you use certainly, but not the actual socket object because there's a boundary there you can't do. Okay, well I think I'm pretty much out of time. If you have any other questions, I'm glad to meet you outside or over in the lounge area. And thank you for your attention.